Hello everyone. In previous lecture we have seen electromagnetic induction. So what is electromagnetic induction and the activity related with it? Electromagnetic induction is nothing but the phenomena by which the EMF or the current is induced because of change in magnetic field near the conductor. So whenever there is a change in magnetic field, the current is induced. So in an electromagnetic induction, the current is induced in the coil. But what is the direction of that induced current? So the direction of induced current was given by Fleming right hand rule. Now John Ambrose Fleming. John Ambrose Fleming gives two rules. One is the Fleming left hand rule that we have already seen, and another is Fleming right hand rule. Now first we will see about what is Fleming left hand rule. We already see the Fleming left hand rule. That is, Fleming left hand rule is nothing but stretch thumb, forefinger and middle finger of a left hand in such a way that they are mutually perpendicular to each other. Then the thumb represents the direction of force or motion of an conductor. Then forefinger represent the direction of magnetic field and the middle finger represent the direction of electric current. So the Fleming left hand rule gives the Fleming left hand rule is used to give the direction of force or the direction of motion of an conductor. So the direction of motion or force of a conductor is given by Fleming left hand rule. Now we have to see what is the direction of induced current. So the direction of induced current was given by Fleming right hand rule. Now what is Fleming right hand rule? Now again similarly, thumb, forefinger and middle finger. Now stretch your thumb, forefinger and middle finger of a right hand in such a way that they are mutually perpendicular to each other. Now see, thumb, forefinger and middle finger, all three are mutually perpendicular to each other. Then thumb represent the direction of force or motion of a conductor. Forefinger represent the direction of magnetic field and the middle finger represent the direction of induced current. So the direction of induced current is represented or indicated by middle finger, and the direction of induced current is given by Fleming right hand rule. So Fleming right hand rule is used to give the direction of induced current, and Fleming left hand rule is used to give the direction of force or motion of a conductor. So we will write the statement for Fleming right hand rule. So Fleming right hand rule states that stretch thumb, forefinger and middle finger of right hand in such a way that they are mutually perpendicular to each other. Then thumb represents motion of conductor. Now we can say motion of conductor or force on conductor. Forefinger represents magnetic field and middle finger represents induced current. So middle finger represents induced current, forefinger represents magnetic field, and thumb represents motion or force on a conductor. Now in Fleming left hand rule, we are also use some notation to remember the law. So here also we use some notation. So for thumb for motion, or we can say force. So Tm or Tf. Then forefinger represents magnetic field. So Fm, and middle finger represents induced current. So Mi. So as thumb, Tf or Tm, Fm and Mi. Tm, thumb represent motion of conductor, or thumb represent force on a conductor. Then forefinger represents magnetic field, and the middle finger represents current. So here we use the fingers, and here we use the direction of motion or force, then magnetic field and the current. So Tm, Fm, Mi. If you remember this, then you does not need to mug up the law. So what is Fleming right hand rule? So Fleming right hand rule states that stretch your thumb, forefinger and middle finger in such a way that they are mutually perpendicular to each other. Then the thumb represent the motion or force on a conductor, forefinger represent the magnetic field, and the middle finger represent the induced electric current. So hope you understand the Fleming right hand rule. We will see an experiment to show a change in current flowing through a coil induces an electric current in the neighboring coil. That is, now we have to describe an experiment to show the change in current flowing through a coil. That is, whenever the current flowing through one coil gets changed, then it induces an electric current in the neighboring coil or in the next coil. So there are two coils. So we have to describe this experiment. For that, we have to take two coils having large number of turns and insert that both the coil on a non-conducting cylinder. For that, we can also use a thick paper roll. So on a thick paper roll, we insert these two coils having large number of turns. So this is coil 1 and this is coil 2. So coil 1 is connected in series with battery and plug key, and the coil 2 is connected to a galvanometer. So whenever the key is closed or the plug key is in, then the current flowing through the coil 1. But whenever the key is closed and the current flowing through coil 1, just observe the galvanometer. Then you can see in galvanometer, the needle deflect towards right and again come to 0. That is, it shows momentary deflection in the galvanometer when the key is in, or when the key is closed and the current flowing through the coil 1. So whenever the current flowing through the coil 1, there is a momentary deflection in the galvanometer of coil 2. It indicates that the momentary current is induced in the coil 2. Now disconnect the key, or key is open. So whenever the key is open, or as we disconnect the key, then current does not flowing through the coil. So again there is, as the current does not flowing through the coil, then again if you observe the galvanometer, then there is the galvanometer deflect towards left and again come to 0. That is, it again show the momentary deflection towards left. So as it shows momentary deflection towards left, that it indicates the momentary current is induced in the coil 2. So from this observation, we can conclude that whenever there is the change in current in an coil 1, so as the starting, that is whenever the key is in, current flowing through the coil 1, or at the end whenever the key is disconnect and current does not flowing through. So there is change in current. So whenever there is change in current in coil 1, the potential difference is induced in the coil 2, and as the potential difference is induced in the coil 2, it induces the momentary current in the coil 2. Now therefore we called it as coil 1 as a primary coil and coil 2 is called as secondary coil. So whenever the current flowing through coil 1, when the key is in, then the magnetic field is produced in the coil, and as the magnetic field produced in the coil is associated with it, and it also associated with coil 2. But as soon as the key is closed, then again the magnetic field get reduced. So the magnetic field associated with coil 2 also get reduced. So due to the plug key is in or off, or we can say the key is open or closed. So because of the key open or close, or whenever the current flowing or does not flowing through the current, the magnetic field associated with coil 1 get changes, and therefore the magnetic field lines associated with coil 2 also get changes, which induces the current. Because as there is a change in magnetic field, that change in magnetic field induces EMF, which induces the electric current. So whenever the current flows through the coil 1 or does not flow through the coil 1, the magnetic field increase and decrease, means there is a change in magnetic field associated with coil 1, and that magnetic field is also associated with coil 2. So there is a change in magnetic field in coil 2, and that change in magnetic field produces a momentary current. We cannot say a permanent current flowing through the conductor, but just momentary current is induced in the coil 2, and therefore we can say that whenever there is change in current flowing through the coil, whenever there is change in current flowing through coil 1, it induces the current in coil 2 also. So this is the experiment, or this is the activity which indicates that whenever the change in current flowing through coil 1, then the current induces in the coil 2. So hope you understand this experiment very well. Thank you.